Hi guys, I would like to discuss one interesting integral problem. Actually, I will use Taylor series over there too. Here is the problem. Let us evaluate this integral from 0 to 1. So the square root of x, and then the cube root of 1 over x, and then the fourth root of x, and the fifth root of 1 over x, and then the sixth root of x, and it goes on like this, and dx in here. So we would like to learn this integral. So for this, I would like to write this integral as first, like the integrand in here, the powers of x, the first one is just the square root, 1 over 2. And then the powers of 1 over x is a square root, cube root, and then this is like if I write it x root, so it is negative 1 over 2 times 3. And then powers of x in here, square root, cube root, and fourth root, so 1 over 2 times 3 times 4. Powers of 1 over x is in here, negative 1 over 2 times 3 times 4 times the fifth root in here. And then times the power of x in here is 1 over 2 times 3 times 4 times 5 times 6. So it doesn't hurt if you just write 1 times 2 in here, 1 times 3, 1 times 3, and 1, and then 1, and so on. So we have this integrand here. It goes on like this, and we are integrating with respect to x from 0 to 1. So if you write this expression, this is integral from 0 to 1, x to the 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial plus 1 over 6 factorial minus, and so on. So we will integrate this with respect to x. Let us first recall e to the negative x, which is 1 minus x plus x squared over 2 factorial plus x to the 4 cube over 3 minus, right? So that would be minus. Let's write it from the beginning. So it's gonna be x squared over 2 factorial minus x cubed over 3 factorial plus x to the 4 over 4 factorial minus x to the 5 over 5 factorial plus x to the 6 over 6 factorial minus, and so on. If you plug x equals 1, so you get e to the negative 1, which is 1 minus 1 plus 1 over 2 factorial minus 1 over 3 factorial, and then plus 1 over 4 factorial minus 1 over 5 factorial plus 1 over 6 factorial, exactly the exponent of x in the integrand. Actually, this would be minus. So, because this and this cancel, so it is exactly. So this integral becomes from 0 to 1. So this integral right here is x to the e to the negative 1 dx. So its integral is x to the like 1 over e plus 1 divided by 1 over e plus 1, evaluated at x equals 1, and then minus x equals 0. If you plug 1, you get 1 over e plus, so 1 over e plus 1, 1 over e plus 1, and then minus 0, so this will be e over e plus 1. I hope you enjoyed this problem. Thank you for watching.